Okay, I'm Ethan Blackwell. I'm in Group 1, the lead for the Experiment 4, which is the Rankine cycle experiment. For some background for the experiment, it is named after William Rankine, who discovered the process. It is the largest source of modern electrical power, so it's the cycle that they use in coal power plants, nuclear power plants, and geothermal power plants, and some large-scale solar power plants also use it. There's 4 phases in the Rankine cycle. The first of which is the pump, which moves the water, increases the pressure. The evaporator, which changes the fluid from a liquid to a gas by heating it up. Sometimes it's called the boiler or the steam generator. The turbine, which extracts the work from the working fluid. And then the condenser, which converts the fluid back into a liquid. So for the theory, this is pretty much summing up what I just said. From during the pump phase, from state 1 to state 2, it pressurizes the fluid by adding work. It is spinning the fluid and giving it energy, which increases the pressure. And the work can be calculated from the change in enthalpy between the 2 states. The evaporator evaporates the fluid by adding heat, and that heat added can be calculated from the change in enthalpies from state 3 to 2. The work produced from the fluid spinning in the turbine is calculated from the change in enthalpy, but in reverse because the work is out instead of in. And then for the condenser, the heat removed by the condenser can be calculated from the change in enthalpy from 4 to 1. The purpose of this experiment is to understand the operation of the Rankine cycle. We need to measure relevant data for the cycle's operation, and then calculate parameters which characterize the cycle's performance, so the efficiencies and the temperatures of the cycle, like thermal efficiency, and then the temperatures at the different states. The apparatus that we'll be using is this Rankine cycle setup, where we have the 4 main components: the pump, the evaporator, the turbine, and the condenser. And then some other components for measuring. We have pressure gauges at different states, I believe, or maybe just one. I'm not entirely sure from the diagram. The voltmeter and ammeter will be used to calculate the output power produced by the turbine. And then we also need a computer with a virtual instrument for analyzing the data. The results we expect, we're looking for the thermal efficiency, which is calculated by the net work, which is the work in minus the work, or the work out minus the work in, over the heat added. A typical Rankine cycle efficiency is around 35 to 45%, and the temperatures are dependent on the amount of heat added, which is unknown at this point, so we can't have any expected results for those. Some sources of uncertainty. There are some quantifiable sources of uncertainty, such as the uncertainty in the voltage measurement that's given, the amperage, and then the dial on the pressure gauge. Some unquantifiable uncertainties would be if we incorrectly followed the procedure and didn't get the exact results that we expected. So in conclusion, the Rankine cycle produces most of the world's electrical power. Their efficiency is usually around 40%, which seems poor, but you know, it's all relative. The temperature and the thermal efficiency can be extracted by knowing the pressures at every stage, as well as the output power of the cycle. All right. Any questions? I think it's propane in the yeah. So that's how the boiler or the evaporator heats up the fluid, goes with the propane tank. All right. Thank you.